Hello, it's Dave Giles here again for the fifth lesson of Cambridge International Education IGCSE Physics, P2 Thermal Physics. And as you can see, today we're looking at specific heat capacity. So two learning objectives for today. The first one is define and perform calculations involving SHC, which is specific heat capacity. And the second one is describe how to perform practical to find the specific heat capacity of a metal. So first of all, little question here. You go to the pool or you go to the beach rather, and you go in the pool and the water feels nice and cool. On the other hand, the sand feels quite warm. Why is that? Now, they've both presumably had the same amount of energy from the sun. We'll pretend these trees here are not offering any shade. So they've both had the same amount of energy from the sun. However, let's say the water has a small temperature rise, but the sand has a large one. And that's because different materials will change their temperature by different amounts for the same amount of heat absorbed. And that is due to something called specific heat capacity. So the specific heat capacity of a substance is the amount of energy in joules required to raise 1 kilogram of a substance by 1 degree Celsius. So, for example, this is 1 kilogram block. I'm going to add a certain amount of heat energy, and it will give me a 1 degree Celsius temperature rise. Now, however much heat energy I need to add to get that 1 kilogram, that 1 degree Celsius rise is the specific heat capacity. So the formula for it is specific heat capacity is energy divided by mass times the temperature change, or you can rearrange that to get energy is specific heat capacity times mass times temperature change, where energy is measured in joules, mass measured in kilograms, temperature change measured in degrees Celsius, and specific heat capacity is measured in joules per kilogram per degree Celsius. Now, a few little caveats to that. First of all is that some IMEs, and quite with Cambridge, they'll give you it in grams instead of kilograms. So then the unit is joules per gram per degree Celsius. Now, the other thing is they might write it slightly differently. So quite often they'll put it as joules, slash, then brackets, kilograms, degree Celsius, close brackets. Okay, so a few slightly different ways this can be written out, but it's usually self-explanatory within the question. So a quick example here, an iron block had a mass of 10 kilograms. Calculate energy transferred by the heater to increase the temperature of the iron block by 25 degrees Celsius. The specific heat capacity of iron is 450 joules per kilogram per degree Celsius. There is a thing there, or a bracket. So let's use the formula, plug your numbers in, and you get quite a large value there. Quite often you might give an answer in kilojoules, so you divide that by 1,000. Okay. So a couple of very quick questions for you to have a go at. I'll pause it, let you have a go through it in a second. Okay, so I'm assuming you've unpaused it now. So the specific heat capacity of a substance is the amount of energy required to raise the temperature of 1 kilogram of the substance by 1 degree Celsius. The first calculation, you've got 2 kilograms, temperature risen by 5 degrees Celsius. You're given a specific heat capacity, work out how much energy is required to do that. So again, just put the numbers in, and you can see there, you are getting 4,500 joules. For the next one here, a very sort of similar question. The only difference is the temperature of the water is 100 degrees Celsius and falls to 78 degrees. So this time there'll be one difference is the fact it's losing energy. However, it's still the same calculation. Also, the fact you've got to work out the temperature change. So the temperature change was 100 down to 78. So that changes 22 degrees Celsius. So SHC, 4,200. Mass, 0.5 kilograms. Temperature change, 22. Put the numbers in, and you get 46,200 joules. And for the last one here, you're given 20,000 joules of energy. It's transferred to a metal block of mass 5 kilograms. Cause temperature of the metal to rise by 4 degrees Celsius. Calculate the SHC of the block. So this formula here, just put your numbers in, and you get 1,000 joules per kilogram per degree Celsius. So let's have a look at some past paper questions. So we're going to look at paper 2 because it's very easy, quick ones to look at. Okay, I'll let you pause it, and I'll put the answer on. Okay, so this one's very straightforward. Just energy times SHC times mass times temperature change gives you 800 joules. Next one's a more descriptive question. Less heat is needed to raise the temperature of 1 kilogram of copper by 1 degree Celsius than is needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. Which statement explains this? The melting point isn't particularly relevant, so it's not that. It being a conductor of heat isn't necessarily relevant. It's going to be about specific heat capacity here, so it has to be B. Copper has a lower specific heat capacity. Quick note here, this is from an older exam paper, so you don't need to know about latent heat, so this probably wouldn't come up on the modern exam. Finally, number 3, paper 2 question. Again, it's just another one where you plug in the numbers and you get 130. And you can see the way they've wrote it here, joules / brackets, kilogram, degree Celsius, close brackets. Okay, so that's the first LO done. Define and perform calculations involving specific heat capacity. The second learning objective is about how you do it practically, how you would actually find it. So we look at these formulas here. You've done energy is power times time previously. However, you haven't looked at electrical power yet, which is something you do need to know for this, and you'll study this later in the course. So power is current times voltage, and energy is power times time. So if you work out the power and energy of each of these, so the current, voltage, and how long it's been switched on, I'll put answers on. It's fairly straightforward calculations. So the way you would find it is by setting a circuit up that looks a little bit like this. So you've got a thermometer in a block of metal, and this here is a immersion heater inside the metal. So this metal's got a little hole drilled in, or 2 holes rather, one for the thermometer and one for the immersion heater. You'd normally add a little bit of oil in here as well, just to help with the initial conduction. And pardon me, you've got a power supply, and you've got an ammeter to measure the current and a voltmeter to measure the voltage. Now, using power is current times voltage, you can work out the power. And then if you leave on for a certain number of time, then you can work out the energy transferred. So let's say here we had 10 amps and 12 volts. That would be 120 watts. Time 0 is going to be 0 across. Time 1 minute, you have to multiply it by 60 because it needs to be in seconds. So you do 60 times the energy transfer. I just said it was 60 times 120 for the power, which would give you 7,200 joules in 1 minute. And the temperature is what you would record after 1 minute. And you do have to say 15 minutes. If you then plot temperature against work done or energy here, you can get a gradient. And if you do 1 divided by the gradient times the mass, that will give you the specific heat capacity of the block. You'll know it should be a straight line apart from the very beginning where you get a little bit of a curve whilst the heat is transferred throughout the metal block. So in an exam question, if you've got something on paper 2, you can get a question like this on paper 2, where it will be a little bit on the challenging side because there's quite a lot of steps. So this is one I found from recent years. I'll give you a minute, pause it, and then I will talk you through how to answer. Okay, so first thing we need to do is we've got a heater and we've got the voltage and we've got the current. So we're going to work out the power. So current times voltage, 5 times 12 is 60 watts. And then to work out the energy transferred, we've got the time. So energy is power times time. 60 watts times 300 minutes is 18,000 joules of energy transferred. Energy is specific heat capacity times mass times temperature change. We're going to rearrange that to get temperature change of energy divided by mass times specific heat capacity. So you plug your numbers in. The mass is 0.8. The specific heat capacity is 900. And that gives you 25 degrees Celsius. So the answer here is C. So that concludes the second learning objective on how you would find the heat capacity of a metal block practically. So the next lesson is going to be on change of state. I will post a link down below in the description. Thank you very much, everyone, and I will see you later.